Chapter 11, the Nervous System Integration and Control, Screencast 4. Now, this screencast is focusing on the peripheral nervous system. So now we're going to look at input and output. The next chapter, chapter 12, is going to be focusing on sensory and mostly special senses. So now we're really looking at what we consider peripheral. Now, this is going to be important because quite often I hear students interchange terminology incorrectly. Neurons and nerves cannot be interchanged. That's really important. A nerve is a bundle of axons wrapped together, and they're responsible for carrying information to and from the central nervous system. So nerves, remember, are part of the peripheral nervous system, and they can go into the central nervous system or they can go out. Going in is sensory, leaving is motor. And if we look at how nerves are divided, we have cranial nerves. There's 12 pairs of cranial nerves, and these are connected directly to the brain. And then there's 31 pairs of spinal nerves that are connected to the spinal cord. So this is how we see information going into the central nervous system, integrated within the central nervous system, which is the next screencast, and then some type of output. Now, as I said before, we're looking at information that's being provided for both the somatic and autonomic motor divisions of the peripheral nervous system. All of this incoming information moves into the central nervous system as action potentials from sensory neurons are located throughout the body. Now, we'll talk a little bit more about some areas within the brain that are critical, and there has to be a filter. Imagine if your body responded to every single piece of sensory information that it's being flooded with all the time. It would just drive us crazy. So we've got built-in filters and things like that that we'll kind of address in the next screencast. Now, we're going to look at output. So this is the somatic division, voluntary, and this specifically controls skeletal muscle. So conscious control here. Now, there are some voluntary reflexes that are mediated at the level of the spinal cord. Now, these are not voluntary, and there's very little higher level function here. If I look at the flexor, so let's say you kind of forget the oven's hot and you go to grab that pan of cookies you're making. You drop it immediately. You don't have to think about that at all. It just happens. If we look at the crossed extensor reflex, and then also a stretch reflex, and that plays a really major role in maintaining upright posture. So let's take a look at some of these reflexes, and we're basically going to work our way through the numbers. And this is actually going to be a combination of the flexor reflex or the withdrawal reflex and the crossed extensor reflex. So all of this is quite often happening simultaneously. So here we see this person stepping on something sharp, and that's the result of a painful stimulus. Now that is going to move along a sensory neuron, and that's going to move into the spinal cord. When we start talking about the spinal cord, there's a couple of things that I want to make sure that you're comfortable. The dorsal or posterior aspect is sensory. The ventral or front part is motor. Okay, so let's follow the pathway. Okay, so here we see an interneuron, and then really we have the motor output. And what that's doing here is there's the withdrawal reflex. That's actually going to pull the leg away. Now, I better have something else going on, because if I don't have something happening to the left leg, we got a problem. So let's look at what happens. There's another interneuron here, okay? And then notice what happens. I now have motor output to the left leg, and this is the crossed extensor. So this is actually creating my left leg to extend so I can actually support myself as I pull my right leg away from the sharp stimulus. So really good example, and none of this is high level. This is all a reflex that's mediated at the level of the spinal cord. Now, the autonomic division, you might want to think automatic. This is the output also of the peripheral nervous system, and this is going to be responsible for most of our bodily functions and maintaining homeostasis in our internal organs. Now, there's two divisions here. we have the sympathetic division and the parasympathetic division. Now, one thing that's going to be important is this concept of dual innervation. And I'm going to use the heart for an example. Okay, so the heart is going to get signals from both sympathetic and parasympathetic. Okay, kind of imagine if you had a radio or a sound device and all you can do is turn it up. Okay, that's not an effective way of doing things. So we want to think of the autonomic nervous system as a control switch. I can turn things on, I can turn things off, but at the same time we have to remember they're kind of activating, they're both working at the same time, but one is predominant. Okay, that's going to be something important, and we'll especially address this when we talk about the cardiovascular system. Now, the target is going to be smooth muscle, cardiac muscle, and all of our internal organs. So most of these internal organs and other structures have receptors for both sympathetic and parasympathetic branches of the autonomic nervous system, that concept of dual innervation. Now, one thing that I want you to keep in mind here is they oppose each other, okay? So don't think of sympathetic as primarily excitatory and parasympathetic as inhibitory. If the sympathetic does one thing, the parasympathetic is going to do the opposite. Now, when we think of the sympathetic division, we're going to look at fight or flight, life or death. So this is the part that's preparing the body for emergencies, or let's say a bad accident happens and you start to bleed or your blood pressure drops. That is going to activate the sympathetic nervous system, and it's going to respond in such a manner to try to reverse those actions. So if we look at some common things that are going to stimulate or what happened during fight or flight, you see an increase in heart rate and respiration. Blood pressure is going to be elevated. Pupils are going to dilate, so more lights get in, so you have better vision. And at the same time, during a life or death or fight or flight response, digestion and urine production aren't really major things. Okay, so they're actually going to slow those things down. Okay, so that's all about the sympathetic nervous division. And the other thing that you want to remember here is the neurotransmitter that's primarily involved with the sympathetic nervous system is norepinephrine. So norepinephrine is the primary neurotransmitter associated with the sympathetic nervous system. And once again, there's a lot of branching here, so there's a lot of things happening at the same time. That's another really important characteristic of the sympathetic nervous system. And as I said before, sympathetic activity is going to oppose parasympathetic activity. A really good example where sympathetic activity is going to be dominant is during exercise. Okay? So keep that in mind. That's something to kind of think about. Now, the parasympathetic, the term here is rest and digest, or rest and repose, and this is the branch of the autonomic nervous system that is primarily activated at rest. So remember, it opposes the sympathetic division, and here the primary neurotransmitter is acetylcholine. So things that are going to happen when the parasympathetic nervous system is predominant, you're going to see a decrease in heart rate and respiratory rate, but we're going to see an increase in activity of the digestive system. So those are things we want to kind of keep in mind here. And as I said, both of these branches of the autonomic nervous system work antagonistically to maintain homeostasis, which was introduced in our last chapter, chapter 4. Now, here on the left, or your left, as you're looking at the screen, you see sympathetic division on that side and parasympathetic. Now, another name for sympathetic is based on its anatomical origination, so thoracolumbar. Okay? Whereas the parasympathetic is originating from the cranial and sacral areas, so cranial sacral is another term that you might see. So let's look at some of the things that are happening here. Okay. Now, I do want to kind of point out here, I don't like this dilate blood vessel. Our blood vessels have very few cholinergic receptors. Basically, vasodilation is primarily achieved by removal of sympathetic activity. Okay, so that is kind of, let's not think that. Okay, but notice what happens. Okay, if we see pupils being dilated by the sympathetic division, they're going to constrict by the parasympathetic. If we look at decreasing salivation during sympathetic, parasympathetic is going to increase salivation. Heart function is really easy. So sympathetic activity results in an increase in heart rate. Parasympathetic will result in a decrease. You get the idea, okay? But once again, it's very important that you understand, okay, how these work together, but it's antagonistically in an effort to maintain homeostasis. Here, these are the two primary neurotransmitters that we're going to see for the most part of the somatic and autonomic divisions. So if I look at somatic, remember that's voluntary. And if we look at the neurotransmitter, it's going to be acetylcholine. But also if we look at the number of neurons required to reach the target cell, there's only one. So when a motor neuron is leaving the spinal cord, it goes directly to the effector. That's not the situation when we talk about the autonomic nervous system. There's going to be preganglionic and postganglionic neurons. So they actually have two neurons that leave, or when it leaves the spinal cord. Now, sympathetic, fight or flight, and the primary neurotransmitter is going to be norepinephrine. And then if we look at parasympathetic, that's going to be rest and digest for the most part, and the neurotransmitter is going to be acetylcholine. So those are things that you definitely want to be comfortable with.